Hi guys, in this video we will be discussing the relationship between an equation and its graph. How do I relate an equation to its graph? We will realize that a graph is actually a representation of all the solutions of that equation. Solutions make the equation true. We will use this to make sense of the fact that the intersection of the two lines on the graph must be the point where both equations have a solution at the same time. So let's look at that. Here we have two equations. Well, what does an equation mean and how does it relate to its graph? So first off, let's graph this guy. We know the slope is m when we have the form y equals mx plus b. The slope is m, so in this case 2, and the y-intercept is b, so in this case -1. So we'll start at the y-intercept, -1, and then we'll count out the slope. This is really 2 over 1, so when we do rise over run, we're going to do 1, 2, 1, 1, 2, 1, 1, 2, 1. So we know this looks pretty good because it's fairly steep and it's going, when I'm going left to right, it's going up like that. So it's a positive slope. So there you go. Okay, so there's the graph. That's fancy and all, but what does that really mean? So as we said in the beginning, one of our points is to realize that a graph is a representation of all the solutions of that equation. A solution is something that makes the equation true. So every single one of the points on this line should make this equation true. So every value along this line, doesn't matter where you are, has an x and a y value, an ordered pair. So I can take any of these and plug it in and it should be true. So let's try a couple so I'll prove that to you. 0, -1. That means x is 0, y is -1. So if y is -1 for the first equation, that equals 2 times 0 minus 1. 2 times 0 is just 0, so -1 is -1. That's a solution to the equation. Let's try another one. How about way up here? That is 5, 9. 5, 9. So if x is 5 and y is 9, then we have 9 equals 2 times 5 minus 1. 2 times 5 is 10. Minus 1 is 9, and 9 equals 9. So solution. It doesn't matter what it is. If this point here were 1.5, 2, as it is, looks like this point here could be 1.75, 2.6. I'm just guessing on those, but it doesn't matter where you are. You can be in between or whatever. It doesn't matter where you are. If you plug that into this equation, it's going to work. It's going to give you a true result. That's the point of this. All of these are solutions. That's why we make the graph. So for the other one, let's do that real quick. M, what is M? There's nothing in front of here. Well, that means it's 1. It's 1x. But it's a negative, so it's a -1. -1, and B is a +5. Oops, equals +5. So we'll start at +5, and then I'll count out -1. But that's over 1, of course, so rise over run is -1, 1, -1, 1, -1, 1. And my line right there. And of course, that is all the solutions to this equation, y equals -x plus 5. Let's try one so I can prove it to you. How about this? 4, 1. That's a nice easy one. So y is 1, x is 4, so -4 plus 5. -4 plus 5 is 1, and 1 equals 1. Of course, it's going to work on all of these. So What is something that's going to solve both of these equations at the same time? Well, of course, that point is right here. The one where it works for both of them is the point where both have a solution. This is a solution on this line. This is a solution on this line. So it's clearly a solution on both lines. Let's try it real quick. That is the point 2, 3. 2, 3. Let's plug that in. 2, 3 for the first equation. So that means 3 equals 2 times 2 minus 1. 2 times 2 is 4 minus 1 is 3. 3 equals 3. Hooray! For the next one, 2, 3, that means 3 equals negative 2 plus 5. Negative 2 plus 5 is 3. 3 is 3. Hooray! It works for both of them. That's a coincidence that they're both 3 equals 3. But the important part here is that it works for both of them. So as you can see, what we have learned is that a graph is a representation of all the solutions of that equation. It represents every solution to this equation. That's why it's drawn on there. Therefore, it makes sense that the intersection of two lines on a graph must be the point where they both have solutions. Both equations have a solution at the same time at the point where they intersect. All right.